Okay, here's an example of a synchronous TDM problem. And in this problem, we've got three different input bit rates, 300, 450, and then 600. We've got two of them at 600. No framing bits and no empty time slots to accommodate the slower channel. So let's draw a little picture of what's going on here. We've got a 300, we've got a 450, and we've got two 600s, all coming into our TDM multiplexer. And then on the output side, we've got to build a frame, and it's going to have a data rate of our total. And I could call these input signals A, B, C, and D. And so 300 is our A, right? Okay, so the trick here in designing this frame is in looking at what is the greatest common divisor of these three different data rates. And 150 goes into all three of them, and it's the greatest common divisor. So in the time it takes for two bits to arrive on source A, 3 bits are going to arrive on source B, and 4 bits are going to arrive on source C, and 4 bits are going to arrive on source D. Okay? And so this is going to be our frame design. And what we can do is we can double check this when we calculate our signal's frame rate below. We are going to eventually assume byte-wise interleaving, in which case each of these little letters here represents a byte. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 bytes. And 8 times 13 is 80, plus 24 is 104 bits. 8 times 13. 3 times 8 is 24 plus 80, yes. Okay, the multiplex signal rate is just going to be the sum of the input rates. So it's 300 plus 450 plus 600 plus 600, which is 1200, 1500, 1950 kilobits per second, or 1.95 megabits per second. Okay, we want to calculate the multiplex signal's frame size and F, and it is 13 bytes, and it is 104 bits. We already calculated that. Here's the interesting part, the multiplexed signal's frame rate. What we're going to do is we're going to calculate our frame, and if all the inputs had the same rate, it would be just R1 over N, where R1 is the bit rate of the input signals, and N is the number of bits per signal in a frame. This equation works when they all have the same speed. But if they have different speeds, we have to break it out and make sure that the data rates and the number of bits in a frame from each of the sources all agree with each other. RC over NC, RD over ND. Okay? Let me straighten this out a little bit here. Okay, all 4 of these must be equal, and in fact they are. Let's just double check. For RA, we've got 300 over 2 bits from source A. For source B, we have 450 over, there were 3 of them from B. And for these two, we have 600 divided by 4. And each of these yields 150 kiloframes per second. Okay? And so that is our frame rate. Hope this helps. This one was a little bit tricky because of the 3 different data rates, but it's kind of fun to figure out how this is all working, and I hope it makes sense.